And yeah, I think exams start on either Wednesday the 13th or Thursday the 14th. Now, this is a single section class, which pretty much means that um, we won't be having a final exam during the final examination period. We will have a final exam on the last day of class, which means our final exam is going to be April 8th. Yeah, let me just check and make sure because I'm thinking Good Friday 2022. Yeah, Friday, April 15th. So we got April 8th, which pretty much means then that next Friday is our last opportunity to um, go and cover materials. And so that's one of the reasons why today I'm going to jump on arrays, and then next Friday I will jump on file management, being able to, because as engineers, most of you are going to have to, well, let's just say file management and disk IO. So let's say you write a program to run on an Arduino, and that Arduino is taking IRQs from some sensor pins, and you got one sensor pin that is sending off a voltage from whatever, and you got another sensor pin, and you got to be able to take all of that in. You got to be able to take all that data in and arrange all that data as a file and whatnot. So that's what we'll talk about next week. Today, however, your assignment last week, as far as writing the program to simulate a card game, gave you the opportunity to look at loops, and being able to look at decision statements and so forth, and giving you the opportunity to look at all of those, creating all of those variables and whatnot. Now, I'm going to show you today, because some of you created 3, 4, no, not even 4. Some of you created 20, 30, sometimes as much as 50 different variables. Okay. To do whatever it is you needed to do based on how you thought the program could work. Let me say right now that computer programming is the art class of the science and engineering field. There is no wrong way to draw a flower, and there is no wrong way to write a program to simulate a card game. And but I will tell you that today's chapter 5, introduces you to something called arrays. Okay? And arrays are alleviate the need to create a whole bunch of different variables. All you need to do is create one variable and have this variable act like a container. And this container is very much like a beer box or a Vitamalt box. We've all seen them. In order to protect the bottles, you have cardboard separators, do you not? All right. So let me see if I could see if I still got it as far as being able to. Whoa, what's going on there? Oh, that's what's going on there. So let me talk about an array. the array is the name given for the container, and that container is going to hold elements that have some kind of common thread or some kind of common characteristic. All right. And when we set up the container, we set up the container in such a way that there's an equidistant. All right. There is no beer bottle or a case of beer box, which will fit comfortably. And you know, you design the beer bottle to fit 24, right? So I've drawn here. You get 6 and 6 and 6 and 6, so you get 24, right? So a case of beer or a case of Vitamalt, 24 bottles. You cannot put 23 bottles in here and then slide in a bottle of Hennessy in one of these. Okay? If you've tried, you found out that there is no space. The space, the diameter for the bottle of Hennessy is almost twice that of the Bud Light or the Golick or Heineken, whatever, right? So what does that mean? What does that mean? Well, it says that the beer, the case of beer, has been dimensioned in two aspects. One, 24 bottles is the first aspect. And two, each slot can only, let me widen this a bit, can only fit beer bottle sized bottles. You know what? Let's make this look a little better. All right. And that's the aspect as far as the dimensioning. And that is exactly what we need to do as far as computing is concerned. So now, okay. Hang on one second. Yeah, all right. So so this is the beer box, and in computing we have arrays. Now, in C++, remember, in C++, we borrow from the C language. Recall that C is one of the more senior languages. Now, modern languages built from the ground up have a totally different approach. And I'll explain what I mean by that. In C++, we have single dimension arrays. Now, an array is a matrix, right? Now, the bare box is, it helps us to say, all right, it can hold 24 bottles, and each the size of the bottles that it could fit is fixed. And in that, it is sufficient to describe an array. But there's another aspect of it which is a little misleading, in that the array is a matrix, and it is a single dimension matrix. So we are used to row column matrices, correct? If we have A, which is a 2, 3, then that is a matrix of 2 rows, 3 columns. So 12, 10, 94, and then the second row is negative 15, 6, and 0. And this is a 2-dimensional matrix. Dimensional matrix. A computer cannot do this. In C++. All right. In C++, we only have single dimensions. So where you would have to say A, and if it's 6 elements, well, you use square brackets first of all. Now, here's the interesting thing about it. You say 6, right? But here's the thing. You're going to set up 12, 10, 94. Oh, come on. Negative 15, 6, 0, close square bracket. All right. So that's how you're going to have to set that up in C++. All right. Furthermore, and you know what? Let me see. I know this is probably going to wreck my beautiful creation. Oh, no. All right. I am pleasantly surprised. Let's come up here. And is that going to? Yeah. All right. In computing, we have arrays. That's fine. We can do that. And go over here. Now, in math, and I know you guys are just eating this right up right now because this is real simple stuff to you guys, right? Note, somebody's saying something in the chat. Oh, thank you very much, Tyler. Where is my... more
recording in progress.
Now we have recording in progress. Thank you, Ms. Bain. Thank you so much, because I know it really helps not only those who are in the lecture, because I've gotten your messages. People are saying how it's so helpful to be able to go back and listen to the recording. Oh, and I found a way to upload. You know, Zoom allows me to record both the video of my screen as well as the audio. And I found a way to upload the video. So I think I'm gonna, well, hopefully they're still on my hard drive. I'm gonna try and upload videos from the start up to present, and just I'll slot them into the week uploading so that they match the subject. Rightio, where were we? Okay, so note in mathematics, yeah, come back playing around me. I can get you. Okay. In mathematics, the treatment of matrices is the identification of the coordinates for the item in the matrix. So A 2, 2 is 6. And A 1, 3 is equal to 94. That concept is not lost on any of you. First row, third column, boom, I go first row, third column, 94. Second row, second column, I go second row, second column, 6. At this point in your academic career, for you to get into a 300 level computer programming class, I know you've been through a pre-calculus class at some point. Some of you probably even did it way back in high school. So I ain't even worrying about that. The problem is, and I need you now to do a little switch. Arrays use the rather awkward computer methodology of counting starting with 0 as the first element. So for A6, 12, 12, 94. That was supposed to be 10, but anyway, 94, negative 15, negative, not equals. So this was supposed to be 10. Right? We start from 0. So we say A0 equals 12. A1 equals 10. A2 equals 94. It's really counterintuitive, right? We've been counting starting from 1 all our lives. And some genius in computer science has decided that we must now count starting from 0 and end in a number that is 1 less than the size that we have dimensioned our array to. So take a look at it, read and inwardly digest it, and then we go from there. Now, so this is matrices. Let me save that. And I've probably made the grand mistake of whizzing through the first like 15 slides in my little white whiteboard. But anyhow, we're going to talk about arrays. And in our objectives, we're going to do a lot of functional description. We're going to learn a lot about the function. I've told you in a nutshell what an array is. And before I get to that, let's go back here. My apologies for twisting and turning you around. While this is true for all languages, we find that the more modern languages, like BASIC, Java, etc., allow for multi-dimensioning, which takes it and puts a whole other spin on it. So in math, a comma 2, 3, a bracket, sorry, 2, comma 3, close bracket, has 6 elements. And in BASIC, we can have a 2, comma 2, comma 2, which is 2 times 2 times 2, which is an 8-element matrix. And in Java, we can have and however many that is, and we can go from there. All right. And that's the one limitation of C++ with respect to its inability to multi-dimension in the same way that these more modern languages can multi-dimension. You go around it by just saying A1 is 6, A1 open bracket 6 close bracket. In C++, I would A1 6, A2 9, and so all of these are A3 12, and A4 15. And so that would be how I would get around that limitation, just kind of giving you a troubleshooting tip or hint. Okay. Right. Well, yeah, we done with this one. So now let's get back to the slides. So we'll go through this dimensioning, introduction, functions, programming, looking at how C++ does multidimensional arrays and array definitions and so forth. Now, all right, so basically I already said, an array definition, a collection of data of the same type. We do not expect to open a sealed collic case and find a banana stuck in one of the squares. For those who really enjoy collic, that would be most upsetting. So one of the things we do is we look at the ability to group similar items. And so when we were the predecessor for Banner, which was Power Campus, when I installed that at UB, we were setting up these arrays in that database. And so we had an array called FNAME. The array was dimensioned to 12,000 because we had the intention of making the initial dimension. We had the intention of making the program capable of registering the existing 4,000 students at UB and then being able to reference at least 8,000 previous students. Okay. And so there was a whole scanning project to get all that data, because a lot of that stuff was either in print form or was in an existing older database from IBM. And we had to port that over into Microsoft. Really fun stuff. And is probably one of the reasons why I developed a lot more gray hair as a 35-year-old engineer. But anyhow, that's another story for another day. Fun times. So what do? We call it, grouping. We essentially dimension the array and declare the array at the same time. And so we have to, just like how we were to say int, or not int, we were to say int A or int B, where we define a variable called A, and we dimension it as an integer or float or double precision or long int or lint. No, I think in C++ it's just long. But anyhow, and then a SHA variable for character. Okay. You can then dimension an array to handle a bunch of names. And so you can have an array, you'll say char, and then you'll call f name, and then we dimension that to say 50. Since we have f names, then it makes sense to have a char L name, yes. So we have f name for first name, L name for last name, and same 50. Okay. And we have all sorts of things, especially with us in engineering and science. We make use of arrays. As a graduate student, where I was working on collecting data we were basically determining the capacitance of the material that is currently used on the space station, even the James Webb Telescope. Now they're still using some of the data that I used for that blocking shield on the James Webb. That is, there's 4 of them. It's made of Kapton. This material called Kapton, produced by DuPont, has tremendous capacitive values. So it's able to separate charge. So all of those subatomic particles that are a part of the solar wind, they get caught up, and what is able to tunnel through the first layer, some get stopped by the second layer, then get stopped by the third layer, and hopefully nothing makes it to the 4th layer or beyond, to the sensitive telescopic equipment that the shield is there to protect. In addition, Kapton is used as a backing substrate for the solar panels, which have they extend and then roll out, to collect photons for electrification. But anyway, enough of that. What I did was I had values for as my apparatus, which was simulating space, as I brought down the vacuum and it became a more rarefied atmosphere inside of the bell jar. I had a sensor that was taking that reading in, and at the same time that it was taking those readings, I had another device which was setting up a frequency on a weight which was placed on top and the metal at the bottom. And so as the atmosphere was removed, we would measure the change in capacitance, and in real time. And so we'd create a nice XY graph, atmosphere on the x-axis, capacitance value on the right. And, you put a set frequency in, and as that frequency changes, you know what the frequency in is. You put a load resistor in series, then you have the sensor, and then to the sensor, you have a frequency counter there. And that frequency counter basically is measuring the change in the frequency, perhaps even the phase angle, all of that lovely stuff. But I was able to take all of that stuff and pull that into an array, and then use the array. And there was a heating element, so I'd make runs for different temperatures, and then produce really lovely graphs showing atmosphere versus capacitance at varying temperatures, and be able to just let the computer make these calculations to do these things on the fly. And so they're giving examples, test scores, temperatures, names, et cetera, et cetera. But I think it's far more, my example of what I did in grad school gives you a little more of an idea of what you can do. I know some of you may be compu-sci majors, some of you may be math majors, or even some of the other sciences, pure sciences, sorry. And some of you are engineering majors. But I think all of you would appreciate the flexibility that comes into being able to do this. All right, it avoids declaring multiple simple variable names for each discrete data element. And you can manipulate the whole list, put the list in a for loop, and just run through that list and have it print out all the values, or have it work on all the values and do what you got to do. So, declaring. What is declaring? In regular C++, when you declare a variable, you're telling C++ that, hey, I expect this variable here to handle this type of data. But when you declare an array, not only are you informing the computer that I expect this type of data, but I also expect this number of elements to be stored. And they quite interestingly have it set up here. Score 0, score 1, score 2, score 3, score 4. All right. Now, this is a bit misleading. So let me, whoa. Let me make it, because I know somebody's going to be, oh yeah, I could go ahead and just put fname1 and fname2. No, you cannot do that. You must utilize the square brackets. The square brackets, you'll note, in your compiler is in itself a declaration tool, and it's a declaration tool that tells the compiler, hey, stop the presses. This is an array. So therefore, you cannot use for regular math. Remember when I said you cannot use the curly bracket in your equations, because the curly bracket separates program lines, right? And separate I'm just seeing what this means here. That's why they put that there. Okay. Score 0. Right. Okay. So basically, with the author, I just see it. The author is saying similar to declaring 5 variables, all integers, score 0, score 1, score 2, score 3, score 4. Anyway, individual parts can be called many things. We call them index. We call them subscripted. We call them elements. All right. But the fact of the matter is that they are numbered to numbered from 0 to 1 minus the size that you've dimensioned the array to. All right. So that is the declaration. And it's important. Oh, another thing, when we are declaring regular variables, I had indicated, an integer holds 1 byte of data, a long integer 2 bytes of data, a floating point number is 2 bytes of data, a double precision floating point is 4 bytes of data, etc., right? I went through all of that good stuff. With respect to arrays, declaration of arrays is critical because when a computer dimensions an array, a computer really, instead of finding just the 1 byte of data somewhere in memory, a computer will literally go in memory and carve out a chunk of data. Now, let me see if so if you look at from the 0 byte all the way to the whatever, you got 8 gigs of RAM, right? So you got 0 up here and then 8 billion going all the way down there. When you dimension an array, all right, is going to take the address, the first address, and it's going to set aside a subsequent listing of memory spaces. Okay? And here's where memory management and actually where C++ is actually used to create viruses. Because when you do things like you have your computer create an array or dimension an array, and then you have all of this space taken up, and then you start moving information around from memory and start pillaging information or just copying the data from elsewhere in memory into some space in here, maybe A2 or maybe A4 and whatnot like this. You're therefore able to be doing stuff that, let's remember, a virus is really something, it's a program that performs a function that the computer does not need or desire. And so when you have when you have a program that dimensions an array and then starts just taking data and just starts moving data around into memory and pulling it into these areas here, then now the program that you've written can now lift this data out of the array and read that data. And that data could be things like passwords, that data could be whatever, so that's kind of the building block and one of the reasons why you'll note that some of you, you go ahead and you write a C++ program and you try to email me the C++ program, and your antivirus stops you, or the email from the campus email stops you, ub.edu.bs Exchange. Well, that ain't even on Exchange no more. They're using Office 365, which is kind of like the newest version. But anyhow, let me get back to what I was talking about. Yeah. So, okay, we were finished with this one. All right. Now, how do you access an array? We access the array using something called either an index or a subscript, whatever you want to call it, which is the position. You reference the name of the array, and then you use a square bracket and you put the position. Now, remember, the position starts from 0, and if it's a 6-element array, it'll end in 5. So just remember that. In your cout statement, or even if you're using a cin statement to take in variable values, right? Now note, there's 2 uses of brackets. In declaration, it specifies the size, and anywhere else, it then specifies which position inside of the array, otherwise known as the subscript or index. So where it says, all right, we're going to declare an array called score, and it's going to be an integer. And now, sometimes when you dimension these arrays, the subscript doesn't have to be defined at that point. What you can do is you can put a variable in there, and what it will force C++ to do is it will force C++ to only dimension at the time that the array, at the time that value is filled. So it's going to hold off on partitioning up the memory based on until it knows what this number is. Now, here's the pitfall in that. Many times we do so. We dimension the array, we declare the array, and set it up with a variable for the subscript. And then we go ahead and we fill in that variable for the dimension size after we start to use the array. Well, that causes an error, because C++ says, well, yeah, we know that you want us to use an array, but we don't know how big you want this array to be. So as far as we're concerned, this is a non-dimension function going on here. And so we're not going to even bother with it. All right. Now, and like I said, that's the way some compilers do it. Other compilers will go ahead and start putting in, it'll just dimension it to whatever arbitrary size that it needs at that particular point in time, which is dangerous, because if you do that, then you find that if you're relying on the computer to dimension the size, sometimes the computer will go ahead and dimension it to a huge size. And when you have an array that is dimensioned to a huge size, it slows down the running of the computer. All right. And you can also put a mathematical expression in here, n+1, n+2, blah, 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 blah. Okay, so what is the array usage? It's a powerful storage and reference mechanism. And it does wonderful in terms of organizing programs such that data, like data, is now forced to habitate amongst themselves. So, like we say, all the last names, instead of you having last name 1, last name 2, last name 3, etc., now we just have last name square bracket 10. So we are taking up 10 last names, and we have all of them set together. They're even one behind the other in memory. Okay. Now, let's put on our Calculus 3 hat, and you will recall, when we talk about series and sequences, where we talk about the nth element in the sequence, right? And divergent sequences and convergent sequences and all of that lovely stuff that is probably giving you a headache just to hear me mention them. No, I'm not going to ask you to calculate these and go back to those things. No, but just think of where we were talking about nth element and so forth. Just think of that as the same. Just think of that sequence as an array. All of the elements in that sequence, especially if it's a convergent sequence, constitute all of the elements in the array. And just like how you were able to reference by just choosing the value for n equals 1, n equals 2, n equals 3, blah, 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 blah. As far as arrays is concerned, where n equals 1 in the array, we now say 0, 1, 2, 3, 4, 5, okay? And you'll find that with computing, we like to do I and J and K and so forth like that. And then if we need it, then we get to L, M, N, O, and just keep on going. Okay. It could be very interesting when we do that with those multidimensional arrays. Okay. We display all elements of array score, fill the elements. We can do all of these things. We can use a sorting array that can find the highest value, lowest value. We can use char and do a conversion where we jump onto the first letter of the character variable or the string. And then we convert that letter to ASCII code. And then, well, we know ASCII code 223 is lowercase a. I'm trying to remember what ASCII code of capital A is. But anyway, and as you go down the alphabet, so 49 is Z. 249 is lowercase z. I simply add 26 to A, which is 223. And so 223 plus 26 letters in the alphabet give you 229, which would be Z. So A is less than B. If you just go A and B, the computer doesn't, it's a string. And we're saying that char or string, we do no mathematical and logical work on it. That's the definition of a char, right? Or a string. Even if you put numbers in it, since it's dimensioned as a string, it's only going to be the string character of that number, not the actual numerical value. And so when we use an array, F name and so forth, and we want to sort it in alphabetical order, sort the names in alphabetical order, we have to go into the function, and we have to use a function that first of all strips the first element of the character variable and finds what that first letter is. Then once it finds what that first letter is, it does a conversion function and it converts that letter to the numeric of the ASCII. All right, the ASCII code. Once you find the ASCII code for that number, then you could see whether that number's ASCII code is greater than or less than the ASCII code of the first letter of the other name that you want to convert them to. All right. So our first program for the day reads in 5 scores and shows how much score differs from the highest score. So the first thing we're going to do is we're going to have some integers. We're going to have an integer I, which is going to allow us to track the for loop. And the for loop is going to go from 1 to 5, right? It's not an array, so that's not going from 0, right? But what we're going to do is we are going to enter these values. And so we're going to say, all right, we're going to take some baseline value, first of all, and we're going to say that, all right, let's score 0 and max score 0. And then what we're going to do is we're going to input some other ones. So score I is going to be 1, 2, 3. And notice it says I is less than 5. So when I becomes equal to 5, it's going to kick out. So it's not going to go on I5. So we already started off with I with score 0. And then when I is 1, we compare score 1 to the max, which was score 0. If score 1 is greater than that, then we swap. We now say that score of this I value is now equal to max. And we just go ahead and delete what score 0 was out of max. And then we say, okay, highest score is, it's going to run through this, score 1, score 2, score 3, and then score 4, and then kick out. And then at the end of this, after it does that, it should come to the highest score. And so we have see out, the highest score is max and del scores and there, all right? And so what we can then do is we can now go, I goes from 0 to I less than 5, all right? And then we can do a see out that one by one lists off the score and says how much it's off, lists that particular value and say how much it's off from the max value. Once you get to whatever that particular value is that is equal to the max value, this will be that value off by 0. All right? So go ahead and try to put this into C++, please, using your NetBeans. Okay. Running out of time. Yeah. That's very interesting. Unexpected token. Let me say something. Oh, for the sake of Pete. With my semicolon. There we go. Right here. So you see, we're just typing, and this is the reason why. So 65. You have entered 65. Please enter score number 2, 9, 81, 33, 24. Runtime successful. Okay, so I've put everything in. Yeah, all right, so that's successful. Close it. Now I can finish. And see, this is one of the things we call, sequential programming. Meaning, especially when there's a part of the program that involves, well, is a little more involved. You want to try and test that program. Some people call it prototyping. You want to test that part of the program, make sure that that works fine. Okay, and then there's another for loop here for I equals 0. And I equals, come on, man. Semicolon, I is less than 5. This time we gotta go less than 6. And then I plus plus. Okay, open our curly brackets and close our curly brackets. Or did it close it for us? Ew, it was nice enough to close them for us. How lovely. All right, what are we supposed to be doing that? Right, okay. So yeah, all right, so we're comparing. So we're gonna say Notice they put it in the textbook, they have it on 2 lines. Sorry, on the PowerPoint slide, it's on 2 lines, but it's by right supposed to be in NetBeans. You know, where PowerPoint has a definite limitation on the number of characters that can be strung across. NetBeans can go 256 characters going across. You can be going over and you'd be going, you know, you can be going over to the right over and over and over. Just notice, you know, my cursor is just going to keep running and running and running until it hits 256 characters. Now, hopefully, come on. There we go. All right, so I didn't go too far. And when we run this, okay, so see the output there. So first that number entered was 7, and the score was off by 27. 23 score was off by 11. 18 score was off by 16. 34 score was off by 0, so that is the highest score. 29 score was off by 5, and 0 score was off by 34. Now, notice when we look at our presentation, we see that please enter your score number, and it is run up onto the number of the score. So what we want to do is put a little space in between. You have entered. In the you have entered, it does the same thing. 54. Okay, so I want to do the same thing here. Put a little space there. Okay, so run successful. Okay, so I want everybody to try and put this in. First of all, get this running, then we're going to do a little modification. Or I'm going to ask you to do a little modification.
Hey, Jack, one quick question. Terry, I don't know which one was who. They do some sort of security detail or security services or something like that. They see going on. I mean, that's the stuff that was just like, okay, but yeah, okay, all that. I mean, I don't know which one was who. Terry Osher, I guess, security work.
Getting that arrays always start with 0. And appreciating the fact that even though You can dimension an array to a certain size. C++ is actually going to let you put 7 elements in a 5-element array. Trouble with that, however, is while C++ will not stop you from putting 7 elements in a 5-element array, when it comes time to reference those elements, you will have, as it says here, unpredictable results. And again, this whole memory management thing, because C++ will not do like Java and stop you and say dimensional mismatch. C++ actually allows you to literally read through the memory contents and look at data that is in adjoining programs that would be run on the side of the program or application that you have running, okay? So just be aware of that. Yeah, we don't really need to go into all of that. Now, sometimes it's useful to make the array size a constant. And when you make the array size a constant, that's when C++ is going to stay fixed. Okay? And of course, like it says, it improves readability, versatility, and maintainability. And so, yeah, so you set up some kind of constant, you dimension the array for that, and then you just make use of that in the program. So if at any point that constant is changed, it's changed once, and then that change matriculates through the rest of the program. Arrays in memory, we recall simple variables, allocated memory, and an address. Array declarations allocate memory for the entire array, as opposed to when you have a simple variable and you just have one memory block. They are sequential, they are one behind the other. You don't have one piece on this side of the hard drive disk, and you know the disk is sometimes made up of 4 platters, meaning the hard drive is made up of 4 disk platters. And or 4, you just think 4 CDs sitting one on top of the other, and that's how they are. And you read the top and bottom of the disk. So you can have, in some instances, you can have a file. And when we talk about defragmenting your hard drive, it means that files are on the hard drive. Piece of the file is on one side, this side of this, the other piece of the file is on that side of the same disk, but then another piece of the file is on a whole totally other disk whatsoever, and so forth. All right. And you have the file allocation table, well, FAT. And the file allocation table has a record of all of that. Okay. But anyway, C++, sorry, with arrays, you do away with that. All right. Auto initializing arrays, if fewer values than the size is supplied, we fill in from the beginning and it fills in the rest with zeros of the base array type, meaning if it's an integer array, it's going to just fill in with integer zeros. But of course, if it is a double precision, it's going to fill in with a scientific 0.00 exponent 0. Get my point? All right. Arrays as functions. We can look more at all of those interesting things we can do with arrays in chapter 10. Like I intimated at the beginning of the class, C++, very involved language, and it's a wonderful textbook. Savage's book is really good. It takes you from introductory and can take you up to being an advanced programmer. And once you're done with this class, I really welcome you to continue to your learning in C++. And, there are lots of wonderful online classes that you can take that can further your knowledge and skill. I think we need more Bahamians doing programming. Okay, everybody's jumping off into networking and PC repair and whatnot, and hardly anybody's doing any kind of app development. But app development, while computer security is the hot button topic for now, I've found that the amount of persons that I've been teaching Security Plus certification to over the past 10 years have been dwindling. So it looks like the amount of need in the security aspect, while it's still there, the amount of need is diminishing. And application developers, there's always going to be a need for app developers everywhere in business. Okay, so that's just a word to the wise. We can have index variables as arguments, where you have an index variable handed the same as simple variables, and you can make function calls with variables, where you have a discrete variable in here, or you can have the number or the value itself. Now, the subtlety of indexing, consider you got a function, and the function is calling a to the I, where the value of I is determined first, and it determines which index variable is going to be sent into that function. Now, I can say a to the I times 5. All right, remember, a computer is nothing but a glorified calculator. So it's going to do the calculation of I times 5. We saw that with this example. The computer printed the value of I plus 1. So I times 5, absolutely no issue with doing it. All right. Basically, the only thing is when you write this program, you better make damn sure that whatever I plus 5 is within the purview, or I should say within the boundary of the number of elements of the array. Okay. Now, sometimes you can pass a whole array in as a value, and we just call it basically the array parameter. You have to send the size of the array as well, and it's typically done as a second parameter, usually an integer type. All right, entire array as an example, where we say, all right, you get a function called fill up, and it's passing integer an array called a. Now, you just have open block, close block to say, okay, the value of the, or I should say the position of the inside of the array will be handled at a later point. Don't worry about it. Just know that we're going to be using some other variable. And so you're going to enter some number called size, and now size takes on the number which is defining the size of the array that is being passed. So this is why C++ doesn't give you any grief. Oh, yeah, it is here. All right. It doesn't see that as a problem. I'm saying integer I, score I. Okay, C++ says, okay, fine. So you're going to tell me where this, how big is this at some later point? Cool. All right. Bet. All right. So put that back. Um, and then when you use the entire array as an argument, then you leave off the brackets altogether. So note, no brackets in the array argument. This defines and says, look, I'm going to take everything in the array previously defined. Oh, the array has to be previously defined discretely. Once you set up, okay, 5 elements, boom, and off you go. So how do we set up the array as an argument? Really fast, think of the array as 3 pieces. You got the address of the first index variable, the base type, and the size. Only the first piece, which is basically the beginning address of the array, is passed. And once you do that, then it just utilizes and is now looking at memory. So let's look at all the array parameters. There's no brackets in the array argument, and you must send the size separately. There's one nice thing. You can use the same function to fill in any size array. And this exemplifies the reuse of that function to fill in last name, and then fill in first name, and then fill in test score, and then fill in date of birth, then fill in high school, then fill in high school GPA, and all of that type of stuff using the same function. Constant modifier. Now, recall that when we're using just the name of the array in a function, we actually just pass the first element, and the function then can modify that array. So again, with C++, very powerful. And while this is often desirable, sometimes this can be a pain in the butt, and sometimes this can be very dangerous because somebody gets a hold of the application, gets control of the application. Now, all of a sudden, the application is making modifications to, screen resolution, or the focus window, or, so you can hear how dangerous this kind of stuff can be as far as programming is concerned. So you protect the array contents from the modification by using the constant modifier. And once you do that, C++ is forced to use whatever is in the array, and you can make no modifications. The array itself can make no modifications. All right. Functions that return a whole array. Now, functions cannot return arrays in the same way that regular variables are returned in functions, because you need the use of a pointer, or I equals 1, I equals 2, I equals 3. You need that pointer, okay? And when they discuss some higher level workings of function in chapter 10, you can see how to do that even more. Programming with arrays, partially filled arrays. You got to have some kind of maximum size. All right, yeah. Partially filled arrays example. All right. Oh, global constants versus parameters. Now, constants are typically made global. What do we mean by global? The scope of the function is declared in the main, and it can therefore then be utilized by any functions that have been declared anywhere in the main, and so forth. Now, because of this, you have what we call local scope as well. The thing about arrays, though, is functions can make use of arrays with their particular scope once you have the array size as a constant. And because once that's a constant, then there's really no need to define the size of the array because it's already defined in the main. But sometimes it's good to remind the C++ of these values. Searching an array, similar to sorting in an array. And let me see if I can. Let's explain this. All right, so outside of the main, I've declared a constant called declared size, which is 20. And that's going to be usable everywhere. Program functions that are inside of this program and so on. So I have an array. I have a function, sorry. And this function is called fill array, line 5. And it fills the array, which is lowercase a. And it's got an integer called size, an integer modifier known as number used. And so the precondition size is the declared size of the array. Post condition number used is the number of values stored in the array. And A0 through A number used minus 1 have been filled with non-negative numbers, which is read from the keyboard. And oh, come on. Running out of time. Yeah. Get out of the way. Thank you. Then I have another function called search, which is going to return an integer value. The precondition is that number used is less than or equal to the declared size of A. Also, A0 through A number used minus 1 have values. And basically, what we do is we return the first index such that A index is equal to whatever that target value is. So what we're doing is we're trying to sort the value through this array. So first thing we want to do is fill the array. And so we invoke fill array, which is ARR. And remember this ARR, which is of declared size. And then we have list size and target. So ARR matches the fact that fill array has been dimensioned as a function that's going to take an array, an integer, and another integer. So fill array says, okay, this array, which is now referenced as the whole array, which is array declared size. Declared size is already set up as a constant, can no longer be modified to number 20. So it's ARR 20. And all right, the number 20 is passed. And then we have this thing called list size. Okay. Now, list size has been dimensioned, has been declared. But it will be received at some other point. Okay. And so we have a do while loop. So it starts off and it says, okay, C out, enter a number for the search. You have C in, and that's target. And then we have result is equal to the search of array list size and target. And so if the result is absolutely equal to -1, then Cout says target is not on the list. And then you just keep on going. And so we have enter up to 20 non-negative whole numbers, mark the list at the end with a negative number. And so once you do that, now you notice it only has 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. Okay, but we are dimensioned to 20 non-negative numbers. And it says enter a number to search for. And it says 10. And then if 10 is stored in array position, sorry, remember the first position is 0. And so 10, it'll go through the list and remember, or I should say it'll hold the counter or index value. Oh, come on. The rest of the program is listed here. Okay, so where I really wanted to get to today is now this particular section of the chapter, sorting of an array. Now, A0 through A9, which is basically 10 memory spaces, have numbers in them. 8, 6, 10, 2, 16, 4, 18, 14, 12, 20. What you do is you start with the first position and you start moving your way down. And once you take the first position and you compare it with all of the values, if there is a position whose value is less than that, then you swap. So you notice you start off with 8, and it's going to say 8 and 6. Well, if 8 and 6 are 8 before 6, if we want to go in ascending order, we'll say if A0 greater than A1, then you'll put a placeholder, which we call temp, and we'll fill the value of temp to A0, then A0 equals A1, then we'll say A1 equals 10. I'll say it again. We set aside the A0 value into some space called temp. Then we set A1 and stick A1 into A0. And now at this point, both A1 and A0 have the same thing in them. But the previous value of A0, the 8, is now in temp. Then in the next line, we say A0 is equal to 10. All right. Now, they're using functions here. But what I want you to do is, and let's jump on this. And go into NetBeans. And we can use the same score. All right. And we can use this to fill the value of score. But now, instead of this thing with max and whatnot, what I'm going to do is I'm going to declare something called temp. All right, so we didn't need all of this. I didn't really check into that. All right, so now I'm going to do an I0, and then I'm going to say, okay. So if score 0 is greater than, oh, come on, score if score 0 greater than score I plus 1, oh, ah, yeah. Okay. What I need to do is I need to add a second level of sorting. All right, if so let's do, so that's when the first number this got to be for J equals 0 to J less than 6. And J plus plus. Yeah. Because I'm going to come here, and then I'm going to go here. Because what it's doing is it's only comparing, it's only making one pass. So Where was my output? In my output, where yeah, it was making it to 0, 1, and 2. But once it gets to 3, the third number, well, sorry, the fourth number. So the 0 number, actually, what I need to do. Because this makes no sense. The I plus 1. Okay. Now let's try it. All right, give me some space. Number from 1 to 10, 54, 90, 83, 29. Whoa. Ah. Oh, this is interesting. Negative 13184. Where did that come from? Okay, and where did my 90 go? I see the 83, I see the 54. Huh. Very interesting. Let's run it one more time, just for good measure. 5, 10, 7, 3, 2. 5, 7, 3, 2. But the 10. Oh, this is interesting. Where did the 10? And then I'm still getting this negative 1 point, negative 13,184. Why? Okay. So the sorting algorithm is now working. First number, then for some reason this 10. 2, 3, 5, 7. All of those are working properly. I need to look at and see whether, okay, so when you'll see the basis, because once you do one pass, if the pass makes a comparison, what it'll do is it'll push a number down. But if that number happens upon a number that is greater than it just pretty much shuts down the sorting. So that's why you got to put J and I, so that the sorting is forced to continue. Now, what I'm concerned about, like I said, is that negative 13,000, whatever that is. And I want to know where that came from and why that's even in there. So you know what I'm going to do? for I equals 0. All right, I'm just going to do here a verification statement so that I know what I'm looking at. And let me just see if that even just cleans things up a bit. Ooh, Bill failed. What didn't you like? Oh, I plus plus 0. Naughty fella. I don't know who invited you to this party, but you are not invited, sir. All right, so 20, 18, 41, 63, and 25. So you've entered 20, 18, 41, 63, 25. The list in ascending order is oh, haha. All right, so I'm entering from 0. I'm entering from 1. I start off at score 0, and then I go 1, 2, 3, 4. But then I got this ridiculous 6 up here. When I really should have put, yeah, I got all these 6s. That's why. 5 and 5 and 5. And then we got a 5 down here too. So 25, 31, 90, 67, 3. 25, 31, 90, 67, 3. Ascending order, the first number is 0, 3, 25. And the fifth number is where'd my 90 go? Where did zero to 5? Well, 0 to 4. because I want to take the 6 numbers. As it looks like it wasn't accepting that last one. So let's say 80, 49, 55, 67, 73. Okay, I got you. Control Z. Okay, Control C. Less than 6. So I go from 0 to 5. Less than 6. Zero, I plus 1. So it's going to give me 1, 2, 3, 4, 5, and 6. So position 0, 1, 2, 3, 4, and 5. All right, are all of these less than 5? This one starts at 0, so that's be less than, okay. Even though I don't even really need this. With this max stuff, because we ain't even doing this no more. So yeah, so we can start that, and I plus 1, please enter score number. Okay. All right, I gotta be able to get that big number in. Score number 1, 23. Score number 2. Hold on, let me give myself some room here. Some elbow room, 45. Then 18. Then 60. Then 45. Okay, why are we? Okay, so we're less than 5 here. Why? So that should be less than 6. Okay, and now let's see. Please enter number 1, 45, 23, 18, 60, and 75. And 12. 45, 23, 18, 60, 75, 12. Okay, now I'm getting there, but now where this negative 13,184 keeps coming up. It keeps coming up. And I know these are the values. I know those are the values. So everything up to the sort is working. Oh, you rascally rapscallion. Rookie mistake. When you use a number, be very careful that the input value of that number has been cleared out. As a matter of fact, you know what? I'm going to take that from there because that has to be cleared out each time this starts. And I'm going to put that here. And so score I goes into temp, that temp goes there. Yep. So temp starts at 0 and then goes to whatever this value is. So temp is equal to score I. Hold on, when I plus 1, so I has the possibility to be, you could have score of I plus 1, which is 6. Because it's literally bringing in an extra value because I don't think that's going to fix it. If my hypothesis is correct, that's not going to fix it. 50, 29, 33, 75, 24, and 18. No, okay. I think I know what's going on. I know what's going on. All right. What's going on is when I is 5, so I go from 0 to 5. I have the 6 values. I'm looking at the score I plus 1. So my logic here is flawed. Okay, that's fine. So if I go from I goes to 0 to 6, if, so that means if I take this and I go up 1, I goes from 1 to 7. But now I say where I had I minus 1 is less than I. Score I is I minus 1. This is I minus 1. And where I had I plus 1, I stay on I. So when I is 1, I minus 1 goes to 0, and I 1. When I is 6, I minus 1 is going to give us 5. So I'm going to go from 0 to, I'm still going to go from 0 to 5. Yeah, yeah, okay. $23, $84, $67, $51, $29, $32. Dang, nabbit, that still don't fix it. The first one is still this negative 13,184. Okay, something is screwy in Baghdad because even when I fix on the lower end, I'm still not getting. So those values are there. And it's just bumping the biggest value. And printing them out. Score I 10. So when I is 6, I'm still getting this. It's still reaching and giving me this value. Which is not where we really want to be. It's almost as if it's shifting the whole list. It's shifting the whole list down. Hey. Yeah, from around me. Yeah. All right. So if the low number is bigger than the high number, I take the low number, stick it in the storage. I take the high number and put it into the low number. Then I take the storage and put it into high number, which is how a sort works. I've cleared out the previous value of temp. So that works. Just for giggles, I'm going to dimension this one larger than what I need, just to test the hypothesis I have here. See if you can guess what I'm trying to do. Yep. Okay. So it's not as though it, yeah. All right. It's finding my lowest number, but for some reason it's putting my lowest number in the second spot, which is not. From a logic standpoint, that makes absolutely no sense. Anyway, I'm gonna have to let my subconscious gel on that for a sec, because we got a couple more slides in this chapter to go through before the end of class. But yeah, I was looking at the right. Okay. Now, multidimensional arrays. Like I said, the whole concept of arrays, as far as C++ is concerned, is really single dimension. But with BASIC and Java and whatnot, you can go through crazy amount of multidimensional arrays. As far as C++ is concerned, there's I guess the way you can look at it is this. C++ is able, in kind of a limited sense, to address multidimensional arrays utilizing two indexes. And basically, we would call it a bidimensional array. So it's just like the Cartesian coordinate system, where the first dimension could represent the X variable, the second dimension represents the Y. This then allows for you to make you can make an array that you can then visualize, or not visualize, but you can make an array that can take in multiple numbers. And if we say new project, C++ application, next, multi-dim array. All right, you go sit down for a while. Yeah, now source files, and then we come here, and then Now, this is a two-dimensional array. And so what you will
Recording in progress.
Now, this is going to be a mess. This is going to give me 100. This is going to give me 100. All right, how do I want to do this? How do I want to do this? Oh. Might as well just copy this because I'm going to be using the same thing. Only thing I'm going to change is that C in statement to a C out. And of course, C out must have that. And each one should be followed by because each X I'm gonna go Y0, Y1. Yeah. Two, three, four, five, six, 7, 8, 9, 10, 11. Okay. All right. So we coming along. All right. Good. So okay, so I don't need these two. So if I take that out, no, I'm going to need Y to be going from 0 to 1. Okay, I need that. I need that. I need you. I need you. But now, how do I get to reference? We got Y0. Oh, that's only going to go once. Oh, because it's only 0 and 1. I don't need Y. I was correct. Get out of here. You are cramping up and hey. All right. Yeah. Okay, so expected semicolon before coordinate on line 43. Line 43, you naughty fellow. Where are you? Front and center. Oh, I didn't put the two less than symbols. Yes, that would cause a problem now, would it not? You know what? Let's be nice to our math pages who are probably rolling their eyes right now. And let's open coordinate. And then let's close. Comma, bracket. Hey, are we good? Are we good? Are we? Are we good? Yes, I think we are. Right, yeah. All right, so let's just throw some numbers in. 3, 3, 4, 9, 1, 6, 8, 5, 2, 1, 11. There we go. Sometimes you just got to think your way through. So the coordinates are, and then off you go. Now, of course, I do not like how the first coordinate is behind that there, and then everybody else is on their own line. There we go. All right. So as you can see, working with multidimensional arrays, very interesting indeed in terms of how we set that up. Oh, wait a minute. Why am I Y values? Oh, duh. My Y values are liking the most man. Okay, so here we go. Less than 2. All right. Always pay attention to what your computer program is outputting. Make sure it's what you're designing it to do. Okay. Yeah, so now we got those values. And just it went 8 caca after it saw this what do you call that, forward slash, which was not, of course, an integer, so it kind of kicked us out. And that's why we basically got garbage from this point on. But I'm happy with this. I'll take that out altogether because that's not really doing anything. All right. Well, yeah, so the video is gonna show what's being typed. All right, so it is 9 o'clock, so it's past everybody's bedtime. It's time to kick bucket. I will look into that. And right now, I'm sure it's something very simple. I think probably I just need to put something in my stomach because I'm just not seeing the the regular array issue. There's an issue here that is very simple, and I'm just not because I mean it's a basic sort, and I need to figure out why it's going to this empty space and including an empty space as a negative 13,100 whatever the number is, and instead of just sticking within the confines of the memory of the array called score. So I'll jump on that and make that available to you via Moodle over the weekend. All right, so All right. So making use of the array, have the array, create a number of arrays where you have an array that's going to accept the student's first name, another array that's going to accept last name, another array that's going to be accepting student number, then an array that's going to accept birthday, and an array that's going to accept birth month, and an array that is going to accept birth year. And then I want you to produce a printout that's going to give the 10 students names and numbers and et cetera, et cetera. 5 spaces between the names, 10 spaces between those and the student number, then 5 spaces, and then the birthday / birth month / birth year. All right. So we'll keep that. There we go. So save. And so I'll post this on Moodle as soon as the video renders, and I'll put all of that stuff up on Moodle. All right. So sorry for keeping you guys so late today. And I'll see you guys next week. Good night.
Good night.